Hello everyone, my name is Yashis from Team 18221 Meta Infinity, and joining me today is my co-host Ajay from Team 14481 Don't Blink.
Hi everyone, welcome back to today's episode of Metacast. Today we are joined by a member of FRC Team 4192 and FTC on Loom, Quinn.
Today we are going to be going over the different types of drivetrains teams might want to use during their season and during matches this year, and we're going to discuss which would be the best option for this game.
Quinn, welcome to the show.
Thank you.
So, to get started, what do you think the most common type of drivetrain is in FTC today?
Well, so I would divide it into two groups. There's tank and holonomic. Tank drivetrains, they can't stray, but holonomic drivetrains, you can. Within tank, you see drivetrains like 6-wheel drive, 4-wheel drive, but there's a lot of variations. Holonomics, it's mostly Mecanum. There's also things like H drive and X drive, which use Omni wheels.
Yeah, great. So you said Mecanum is the most common omnidirectional drive, and then the 6-wheel drive is the most prevalent tank drive, right? That's correct?
I'm not sure if 6 is more prevalent than 4-wheel. Recently, since Rev has edu-kits, 4-wheel might be more common, because most people use Mecanum over 6-wheel now.
Alright, cool.
What's your opinion on Swerve Drive and why is it so popular?
Well, I think this is really controversial. Should I start with what Swerve actually is?
Sure, yeah, that would be
Okay,
really helpful.
so imagine a 4-traction wheel drivetrain, but you can rotate each of the wheels independently and also power them. So it allows you to move in any direction similar to Mecanum, but the wheels have more traction since they use like a tread, such as GGT, and you don't have to slip to change directions like Mecanum. It just rotates. There's two main types, coaxial and differential. Coaxial uses a servo to turn the wheel, like to turn the module, and a motor to power it. It has 4 of these modules, one near each corner. Differential has 2 motors for each module, but there's only 2 modules. Modules are near the center of the robot. The motors can turn and power the wheel, but they can both turn and power the wheel. I think it ends up performing worse than coaxial, mainly just because of efficiency issues and how, since there's only 2 wheels that are powered, it moves kind of weirdly. Swerve can do some really cool things, like you can spin the robot while driving. You see this tons in FRC. For example, last year, people would have their elevator and their end effector in like a set position. They wouldn't have a turret to change it, and so to flip it from one side to make it face one side of the field the other, they would turn their robot using their swerve while moving. And that was really, really helpful. It reduced complexity a lot for FRC, but it kind of just adds an FRC. For which one's better, like Swerve or I would say Mecanum, is what I would compare it to, because they're both holonomic. I don't think it's really possible to give a definitive answer on this yet. Swerve performs worse currently, I think, because there's significant design, programming, driving challenges, and it's not a huge benefit in FTC. You're mainly just getting the better traction, and not even much more. It's not going to make you unpushable or anything. But okay, you can go.
I just was wondering, like, for a lot of our members that are like definitely rookies, like they haven't really heard of like what even Swerve is, and you definitely gave them like a really good definition. But is there like any sort of example you could give that that like could make that could kind of give them a clear visual of what Swerve is?
Yeah, sure. So I'm sure pretty much everyone's seen a shopping cart before. If you look at the shopping cart wheels, they can spin around. Like the module itself can spin, and the wheel can spin. So that's very similar to Swerve. The difference is those wheels are offset from the center of rotation, unlike Swerve.
Yeah, that makes sense. Yeah. definitely whenever I go to the grocery store and I be a shopping cart, I do think of swerve, coaxial swerve. So what is the difference between two-wheel drivetrain, four-wheel drivetrain, six-wheel drivetrain, and even eight-wheel drivetrain? And what do you think is the best? Because like I see like so many different drivetrains coming out every season. I know like differential swerve only uses two wheels, and usually my team just uses a four-wheel drivetrain. But I also see teams like the Brainstormers and Freight Frenzy using a six-wheel drivetrain. So it's just like very cool to see.
Yeah, so we already talked about differential swerve. Wouldn't really recommend it. It's a cool project, but I don't think it's as competitive as a lot of the other types. With four-wheel, there's two main designs. Well, there's three main designs. This design that uses kind of like, if you've seen the Rev Edu kits where you have all traction, all omnis, or like two traction, two omnis, it's usually powered by 2 or 4 motors. It's okay, but I think the other types of drivetrains they just have certain capabilities, like holonomic movement, that make them so much better. Another four-wheel example is Mecanum. It has the holonomic movement. It has decent traction. It's really easy to drive, really easy to program. I would recommend it the most. There's also another type called X-Drive, which uses omni wheels in the corner of the robot, and it also has full holonomic movement. Six-wheel drive, it's not holonomic, but it has pretty good traction. It's better at pushing and acceleration. Now, you mentioned eight-wheel drive, right?
Yep. Yeah.
So I don't think it does anything better than six-wheel drive, except perhaps resisting being pushed from the side a bit more. It's possibly even worse because the extra traction wheels don't really do much. You have to keep in mind that greater surface area does not equate to greater traction, so adding the extra wheels doesn't really do anything. Overall, Mecanum definitely easiest to implement, the most advantages and fewest disadvantages. I know with it, people bring up traction a lot as an issue. It is an issue, but less of one than people think. Because when you're on the field, it's able to sink into the field a bit, and so it performs a lot better than people think by just putting it on, say, a table.
Yeah, definitely. The differences between each tank drive, between 4, 6, and 8, is definitely noticeable, especially between 4 and 6. Less so between 6 and 8, but you can definitely tell that there's a difference, and that usually the key equilibrium point is between 4 and 6. Moving away from tank drive, I kind of wanted to talk a bit more about the different holonomic drivetrains. So we mentioned Mecanum and Swerve Drive, but what are your opinions on Kiwi Drive, otherwise known as X Drive, or even H Drive? What are they, and do you think that they could be possibly better than Mecanum?
So, correct me if I'm wrong, but I think Kiwi is 3 Omni wheels and X Drive is 4 Omni wheels, right?
Yeah, that's correct. I messed up. Yeah.
Okay, so Kiwi, it uses 3 Omni wheels in a triangle configuration and it only uses 3 motors. It's really cheap, but it kind of is pretty bad at moving. It has holonomic movement, but it's not very efficient or very good. X Drive is a bit better. It's closer to Mecanum. I've seen some really good ways to package it. For example, you can kind of put the motors vertical right next to where the wheels are, and some robots that can package more. I saw a couple examples in PowerPlay. With H Drive, imagine a 4-wheel drive with all the wheels being Omni, but in the middle you have a single Omni wheel powered by 1 motor, and it's perpendicular to the rest of the wheels. So when you power that single Omni wheel, it can move the entire robot left to right. Compared to Mecanum, extra motor, it's less efficient. It's kind of hard to package. I wouldn't recommend it.
Yeah, 100%. Mecanum, even though it could slip, it definitely still has probably the same amount of slip as Kiwi and X Drive, which kind of negates the differences between them, and then H Drive just adds an extra motor, so it definitely makes sense that Mecanum should still be the prevalent question.
So Mecanum doesn't really slip as much when going forward and backwards, but the Omni wheels always slip because of Besides H drive, they always slip because of how they're moving.
Yeah, 100%. Moving on, I just wanted to know, why don't a lot of teams use something like a trev drive, or if you go on Gobuilda and look at their Outlaw chassis kit, why don't they use something like that in their room?
Yeah, so I haven't seen one in person, but I think the reason is it just has really bad turning. If you're wanting that extra traction, you should probably just go for 6-wheel drive. And I think it also has pretty bad efficiency. With most tread designs I've seen, I think there is also a chance of damaging the field tiles, but it depends on how you do it.
Yeah, 100%.
I was just wondering about the butterfly drivetrain that we've seen a lot of teams use in previous seasons, like I2 and technical difficulties, and why don't teams use something like Swerve instead of butterfly?
Okay, so yeah, a team I was previously on, I2, ran Butterfly. It's probably my favorite drivetrain because it fixes the disadvantages of Mecanum, the traction issue. So what Butterfly does is it has the Mecanum wheels, and then it also has traction wheels it can switch to. It pushes the traction wheels down and lifts the robot off the Mecanum wheels, and then it uses those. What makes it so good is, since you're using separate wheels, you can actually get a different ratio. And so it's kind of like a 2-speed. You can have a really fast ratio for your Mecanum wheels, which you would normally be driving on. And if you want to play defense, you can switch to much torquey with your traction wheels. So you're getting the extra traction and the extra torque, which if you do it right, it'll be pretty much unbeatable in push and power. Another thing is it's really easy to drive. The reason you do over swerve is it's easier to drive. You keep the fine alignment of Mecanum. You don't have to do program changes, and it's a lot cheaper. And it still has the amazing benefit of being basically a 2-speed, which Swerve doesn't. So if you do it right, it'll outpush any Swerve.
Yeah, so Quinn, I was really wondering, what do you think is the best drivetrain for center stage?
So the way I'd approach this is eliminating all the drivetrains until you find the best one. So we'll start with Swerve. The complexity and the issues with it, I don't think is worth it. With Butterfly, the fence, it's just not very great. So it comes down to basically 6-wheel drive or the Hollow drivetrains, the best of which is Mecanum. 6-wheel drive, I don't think you're going to need the added acceleration, and the fence still, once again, isn't as prevalent, and you lose fine alignment, which is really important for the backdrop. So overall, I think the best is Mecanum. You also want a light, small robot, and the way Mecanum packages is pretty great for that. I've seen 10-inch robots with Mecanum.
Yeah. Thank you so much, Quinn, for joining us today. I hope you have a great FRC season.
Yep, thanks.
And as always, thank you for everyone for tuning into this episode of Metacast. I hope everyone has a great day. We'll see you next week. Bye.